So there's a very interesting debate that I was scrolling through and saw on Twitter where people kind of trying to figure out how could you remove backgrounds from images. And there's tons of third-party service tools that do this, such as Replicate. But I want to explain one of my proposed ideas as to why I think using serverless and lambdas could potentially solve this problem really well, instead of using an actual like dedicated server. So let's first start with what I have built out. So I had this UI that's running locally, and this is using Convex to simulate when these images are processed. Okay, so as we're processing images on the lambdas, when they first warm up, the lambdas, when they warm up, this is going to turn yellow. And then when the image is done processing, it turns green. And so I'm going to send out 1,000 of these to an SQS to process them all. Over here, we have an S3 bucket with 1,000 images in them. So let's just open up the first one so I can show you. Here's an image of someone cooking. I also want to point out that I just replaced the first image with like a smaller one just for fun, but there are also a bunch of 3 megabyte images that are a lot higher resolution. And so locally over here, I have a run script, and when I run it, it's going to publish 1,000 messages to an SQS, but it's actually using send message batch. So it's basically batching 10 messages at a time and sending it to an SQS. And then later that queue is getting picked up by a Lambda, and that Lambda is processing on that queue. You can see over here, we have a Lambda attached to this. And then that's going to remove the background from the image, going to restore the image to over here into this bucket with a different prefix, and then we'll be able to view it. So I will go into more detail about all this stuff in a bit, but let's just demo it out, okay? So let's just go ahead and kick off this script, go ahead and run it, go back to the UI, and you'll start seeing all of these messages come in. Now I will say I did pre-warm the lambdas a little bit to make it work a little bit faster. But when this first runs, it has to slowly like warm up a bunch of lambdas. But once you have a bunch of lambdas warmed up, I think right now it probably has like 300 warm lambdas, it can quickly churn through all those images. And within, I don't know how many seconds it was, maybe 10 seconds or more, we just finished processing 1,000 images and removing the background from all of them. So let's just go ahead and say no BG here. And let's find the first one. Let's open it up, and we'll look at it over here and notice that the background image has been removed. Let's first start with like how this works, and then I'll talk about why I decided to use Lambda and serverless in this. So again, we have like a script, and what this script does is it basically runs and publishes a bunch of messages to SQS. Okay, so I ran that script, and you saw it ingest a bunch of messages. It's doing batch command writes, and then this SQS queue, there's a Lambda here that is basically subscribed to it using a Lambda trigger. And so every time a message hits this queue, a Lambda is going to process that, and then it's going to run some code to remove the background. And so inside of the message itself, if we were to go ahead and put a package here, this has some information such as, you know, what image it needs to process. So like an image ID or something. And then behind the scenes, that is going to pull in the image from an S3 bucket because maybe you have like an actual service where people can upload files that goes into your S3 bucket. Now, the reason I'm doing all this is because I'm assuming you're adding this as a feature to an existing system. So for example, one of the things that I worked on is icon generator. And at one point, if you go to your collection, there was an option to remove the background. So you have all these images, you click a button to remove the background, and that already existed. All these images exist in S3 already. And so that's why I'm just fetching the image from S3. And then I run that background processing, and I basically store it back into S3. Now for the live data updates, again, like I said, I'm using Convex for kind of showing this, and this was just something I added in so I can have a visual. But when this trigger is running, basically what I do is I send in a message saying, hey, this image is currently being processed. And then later when that processing finishes, I send yet another message to Convex. And then we have a UI over here. Let's just say like browser. So this is a browser, and by default, Convex has real-time database updates. So like you'll see all those boxes update from different colors when these lambdas are sending events here, okay? But here's my UI, my simple UI built with Next and React. But that overall is how it kind of works, okay? And like maybe from an outsider's perspective, this is complexity, but like I just showed, like you got auto scaling, being able to do a bunch of different stuff with very, very little effort, in my opinion. Now, this is like the serverless approach. People like to hate on serverless, but I mean, as you just saw, like I just process a bunch of images super fast. Now, I will say, since making this video, it's come to my knowledge that there are other models out there that do this in like 0.4 seconds. And so most of what you're seeing here, you can take the concepts and apply it to other things. Like, so for example, at work, we have the need to take a database record, and then that has maybe 100 or 1,000 associations with it. And what we need to do is we need to loop through every single associated record, generate a unique PDF for that record, and then we store it back in the S3 and we send them an email saying, hey, your records are ready to be processed. And again, this concept is very powerful because one thing that serverless is actually really good at is bursty workloads. So like, for example, a user clicks a button, it may need to do 2 things, it may need to do 20,000 things. You don't really know. This is where serverless really shines. All right, with that being said, let's talk about the other approach. Let's talk about a dedicated server. Okay, so a dedicated server, this is typically you go and you buy a server somewhere. So let's just buy a server. We're going to rent one. Okay? We're going to rent a server. I mean, you can rent a server that has 80 cores for about $224 a month, at least according to Essner. I looked it up. So $224 a month, 80 core. Okay, and this process that I just showed you is very CPU intensive. So every image basically needs a complete core to be able to run, or else you basically just get a complete break of the machine, and it uses a decent sized amount of memory too. So one thing you do is on this little server, you put an API, and on that API, you probably want some type of queue, right? Either that's an internal in-memory queue, or that's external with like Redis or something, but a user needs to come in, and they could make requests directly to your API, and they can send in an image. So they could send in their image like this, and then that API could process on the image, and then it could send it back. But the issue is that you are going to hit a limit based on your cores. You don't want people to just flood your machine with a bunch of images. Maybe you go viral and your application gets a lot of traffic and everyone starts uploading images at the same time. What's going to happen is that you are going to have CPU contention. There's only so many of these workers you can run on a single machine. And so the idea is, okay, well, let's just rent a couple of these. Let's go ahead and rent some of these, and I'll put like a load balancer in front of them so that I can actually fan out the workload, or I'll just suck it up and say, you know what, you guys just have to wait in line. Again, these are all trade-offs. These are like things you need to think about in terms of your business. But I will say that this approach is going to be limited by cores versus this one. You can scale up to about 1,000 Lambdas really, really easily, right? If I were to send more events, you'll see that just scale up very, very fast. And the cool thing about Lambda is the more memory you give your Lambda, the more CPU cores you get. So I think if you get about 2 gigabytes of RAM, gives you like 2 cores. I think if you go all the way up like 10 gigabytes, you're up like 6 or 7 cores. And so technically you could actually process multiple images at once on a single Lambda because SQS allows you to do batching. So let's just say batching over here. And you can group multiple things inside a batch together and send that over to your Lambda. And then your Lambda can actually fetch 5 or 6 images at once, try to remove the background from all 6 of them, and then restore those to S3 when they're done. Another thing that's great about SQS is that it has built-in retry logic. So what I have seen is that sometimes you'll send an image over, and whatever tool that you're using to remove the background, maybe it eats up too much memory on your Lambda instance and the thing dies. Okay. And so now you have an image that's left around not getting processed. I saw this one time where I had a box that was just stuck in processing. The cool thing about SQS will just retry that. All these events that we're sending into SQS have like a max visibility timeout. And so if, let's say 30 seconds pass by, that event is just going to get reprocessed up to 3 times. And then you can actually send that to a dead letter queue. So if I just added another queue here, this is called like a dead letter queue. And you can actually store all the events that failed. And then later you can like trigger them off to get reprocessed at a later time using like a cron job or something in CloudWatch. But the idea is that you have these like little primitives in AWS and you can just hook stuff together and do a lot of processing very fast. And it's really cool. Now let's talk about cost, because that's the one thing that people keep saying is serverless is super expensive. And I'm not going to lie, I'm not going to say it's not expensive. But again, you have to kind of look at the trade-offs. Do you want that flexibility to scale super easily? Or would you rather have that consistency knowing that you're not going to go bankrupt with $224 a month? So let's draw a little graph here. Let's just make a graph. And we're going to go over here and we're going to talk about a dedicated server. So dedicated server, this will be costs. And this was about $224, I think. Okay. So the great thing about dedicated servers, like I mentioned, is that you get a fixed cost. You're not going to go over that, but you're capped. You can't process more things unless you go and start adding more servers and add a load balancer and introduce a little bit more complexity. Now, serverless is a little bit different. You are charged per use. So starting off, you're going to be able to process a lot of images. So I'm going to go down here and say like images processed. And at a certain threshold, you're going to get past too many images where you're actually losing money where you would have saved money with a dedicated server. So again, these are things you have to keep in mind. Do some cost analysis. Does it matter? Does your business care if you spend an extra $50 Let's actually look at some hard numbers because I think you understand the dedicated machine, but it makes sense if we go and look at how much does this actually cost. So if I were to go and do 1,000 requests like I just did, let's go in the CloudWatch and look. So the last run took about 5 seconds, and we were billed for 6 seconds, and then the memory size was 2,000 megabytes. All right, and it only used about 999 of that memory, so I could potentially drop down my memory. But let's inspect how much this will cost. So let's do 6,000 because that's the duration, and then we're going to go down here and say this is 2,000 for the memory. And let's look down at the charges. We were charged 20 cents. Okay, so 20 cents for doing 1,000 images. Not too bad. And granted, there's going to be some costs that are for like fetching from S3, storing back into S3. Most of the costs for like egress and ingress for S3 are free if you keep it inside your network. If you start leaving the network, that's where they usually charge you. But that's pretty good. So 20 cents for that. And I will say that Amazon has like a giant free tier. So technically I won't be charged anything until like I do quite a lot of these. But I do want to keep it realistic. So at what point, how many images would someone have to process for me to no longer get that 224 dedicated server that we mentioned? So let's add a 0 here. So now we're at 10,000 images. We're at $1.95. Okay, let's just go back, add another one. So at 100,000 images. Okay, we're at $19 to do 100,000 images. Let's just add another 0. So now we're at 1,000,000 images, and we're still not even at that threshold. We're close. Let's just add a 1 here, or a 2. Oh yeah, we'll have to do a 2. There. So now we've finally crossed that threshold where it's more cost effective to use a dedicated server. So let's go back to our UI a little bit. And that threshold is 1,200,000 images. Okay, so this is the threshold. That's how many images you have to process in a month where it makes more sense to use a dedicated server. Maybe, again, your processing is going to slow down. You can't just handle a bunch of people logging in on the same day doing a bunch of requests because they're all going to be queued up and then they're going to get a poor user experience. But overall, I mean, that's quite a lot of images. If you have that many people processing on images and it only costs 20 cents for 1,000 images, maybe it doesn't matter. Maybe you just do that as an operational business write-off. Okay, maybe it does. Maybe you want to squeeze out as much money as possible, but sometimes all of the work to set up a dedicated server and make sure it's online, make sure it doesn't completely crash and run out of memory, a lot of that's really nice to not have to worry about that, right? Those are my thoughts on costs. I'm not going to say one's better than the other. They have trade-offs. We all know that. But let's talk about why I didn't just use like a third-party service to do the background removal. One thing is privacy. Do you want your users to upload their images, maybe their photo albums of their families or whatever? Do you want to upload those images to some random third-party service? Probably not. I'd rather keep that all contained inside of AWS, inside my own resources. Not that I don't trust Replicate, but I would much rather trust AWS, okay? Now let's also look at costs here. If I were to use Replicate for doing this, $1 for 256 runs versus Serverless was 20 cents for 1,000 runs. So you're going to save a lot more money if you just kind of roll your own sometimes. Now let's actually look at the performance here. I'm going to go ahead and upload an image. Just go ahead and click on this one, and I'm going to click Run. And let's see how long it takes to remove the background. Okay, so first of all, Replicate, if the thing that you're running, the model you're running hasn't been used in a little bit, it has to warm up, just like a Lambda. But sometimes I've seen it wait up to 5 minutes, depending on if you're using like a not really well-known model. Luckily, this one's been used a lot, 6.6 million runs, so it's probably always going to be warm. But here you go. It took 6.6 seconds to process this image, and you still have some artifacts and some low quality of it, okay? Now, I will say there's some other models out there that could potentially do the image processing much faster. But again, it's all like how much effort is it going to take? I got lucky and I managed to find this, MIT licensed Lambda. I just pulled it in, built a container, deployed it out. You might not get that lucky. You might have to spend a couple weeks learning about PyTorch and Python and pip and all this stuff. But that's another thing you have to think about in cost analysis is what is the effort involved for developer time? If something like this took me a couple of hours, again, I have experience with all this stuff. So this is like a bias talking right now, but it was much easier for me to do this than it would be for me to go and rent out EC2 machines and put them behind some type of auto scaling group, put them in front of some type of mechanism to scale up and scale down automatically so I can save a little bit of money. And then also renting one of these machines, it's not instant. You have to actually go and like fill out paperwork and like get the machine. Sometimes they have to go and set those machines up. Granted, if you're using like EC2 or DigitalOcean, like that's instant. They just spin up the machine in like 30 seconds and you can start playing around with it. But for some of these dedicated machines, there's like days of turnaround time from what I've seen. You guys can correct me if I'm wrong. And the greatest thing of all this is how much did I pay for all this testing I did? I think I've ran this over 20 different times with 1,000 images. So if I go to my free tier and let's go to Lambda, I can't even read how many zeros this is. This is how many 10 million requests are free. And then I'm also assuming there's some type of like AWS Lambda seconds, okay? You get this many seconds for free, which is, what is it, about 4 million, 37,000. Granted, I don't know if this is updated daily or if it's live. It's probably not live, knowing Amazon. But the point is let's say you're at a startup, or let's say you have this idea you want to move quick. You can deploy it out, not get charged too much money for it, and then use the free tier. And at some point, you'll run out of the free tier, and you can actually just start paying some money for it. Anyway, that's my talk. I just hope you guys understand a little bit more about serverless and how it kind of works and when you may want to use it. If you guys enjoyed this video, give me a thumbs up, leave a comment if there's a different approach you probably would have solved this. And like always, have a good day. Happy coding.